I'm honored to introduce our keynote speaker today, Professor Shekhar Mande. He is the former Director General of CSIR and the Secretary of DSIR. Prior to this, he was the Director of National Center of Cell Science, Pune. He is a structural and computational biologist, and in 2005 was awarded the Shanti Swarup Bhatnagar Prize for Science and Technology. I welcome Professor Mande to the stage to speak on the biomedical sciences in India through the ages and in post-independent times. Welcome, Professor Mande.
Alliance for this invitation to speak here. Today morning I was thinking, why am I talking about this particular topic? And I was struggling to find an answer. And I realized that I have once been the International Senior Research Fellow of the Wellcome Trust, with generous funding of my lab at the beginning of my career. I could best find two reasons. I'm going to tell you what the reasons would be. One, I find very often a debate in the society, and by which some of the emotions are so much swayed that the scientific community also starts taking stand in this debate. The debate is like this. The people who practice science in our laboratories, what we call as modern science, very often dismiss the cultural practices as non-scientific, irrational, anti-science, pseudoscience, etc. And that actually is very prevalent even in our community. On the other hand, people who take pride in the cultural practices and the traditions don't really adjust to the modern ways of scientific thinking and outlook and so on and so forth. Between the two extreme positions, there's always a middle path that I like to propagate amongst people when I speak on public platforms, that there is always a middle way that all of us actually should consider accepting. The other debate that goes on about the colonial history is about how the colonial powers tried to destroy the culture of their colonies during the at least in India, 190 years of the colonial occupation. And how some of the cultural things like the education practices and all were being attempted to be destroyed. That's one extreme view. The second extreme view on the other side, which is taken by the colonial people themselves, is that the countries which were not very highly educated in their terms, and the colonial powers actually brought the modern thinking in their colonies. Once again, these are two extreme views. And when I talk of these two issues, either the modern science versus culture, or the colonial occupation versus their colonies, there is a very small minority which actually subscribes to both these views. But the problem with both these minorities of the extreme views is that they're extremely articulate, they're charismatic, and when they speak, people like us also get swayed by their emotions the way they speak. And the views, therefore, the moderate views that people like us would like to believe is the centric path, there is a middle path that almost invariably gets actually overwhelmed by both these. And there are enough number of, in this audience itself, who take these extreme views, right? So what I'm going to do is try to see how the middle ground is. I'm going to have picked up some of the examples from our cultural practices that we even find prevalent today, right? And how actually, if we take the middle path, how does it actually benefit the mankind in the long term? And the examples that I'm taking actually are even practiced today and have helped humanity enormously. And that's exactly what I have done in my talk. So this is the best example I could actually, the best rationale I could come up with, why am I speaking about this particular topic today. Now, having said this, a disclaimer, I have been used to having worked in the government for some time. I was a bureaucrat till recently. And I'm quite used to people telling me that I'm talking nonsense. So if any one of you thinks I'm talking nonsense, please feel to tell me that. So please don't hesitate. So I'm quite used to that. All right. So the first of the examples that I have taken is a very ancient example that has been practiced in India for something like 2,500 years and is even practiced today all around the world. And this is of something called Renoplasty. People are aware of this particular procedure. This is described in Sushruta Samhita, 6th century BCE. And this is about how do you reconstruct a mutilated nose. So the practice is that if a person whose nose is mutilated, and this was a practice during wars and all, that people often coming back from wars, their nose would be mutilated. And to reconstruct the nose, what was done in the ancient periods is to take the skin from the forehead or from the cheek, cut it out, put it on the nose, flap it on the nose, and reconstruct the nose. While doing that, you also put tubes in the nose so that the nostrils actually remain intact. Now, this practice has been followed since 6th century BCE. All right? And the photograph that I show you here is taken from the Wellcome collection. This photograph is from a person who was a bullock cart rider called Kausaji. He was in Pune, and I'm going to tell you the story of Kausaji a little bit. He was a bullock cart rider, and in 1793, he was sent for war to fight the forces of Tipu Sultan in Mysore. And when he came back, his nose was mutilated. And when he came back to Pune, one of the masons actually found out Kausaji's nose mutilated and operated on him. And when the British saw that, they were quite amazed how the nose was being reconstructed. And then the British actually took the practice to Britain and they followed it up, and I'm going to just show you how that happened. But although it was described in Sushruta Samhita, 6th century BCE, the more detailed procedure is described by Vagbhat in 4th century ADE, and it actually has a fairly detailed procedure how to do actually nose reconstruction from the skin of your forehead or from the cheek. And basically it says that you have to take a leaf from a plant, get the shape of the nose, cut the leaf accordingly, put the leaf on your forehead or the cheek, exactly cut that part out, flip it, put tubes in the nostrils, and then paste it back properly there. All right? And then the antiseptics, what we are taught then, and of course these have changed now, are basically to put some kind of honey and ghee and all those things on the part so that they can act as antiseptics. Of course, these things have changed. And when the British actually saw Kausaji's operation 1793 in Pune, it was taken to Britain, and the first person who did this operation in Britain is somebody called Joseph Karpu, Dr. Joseph Karpu, in 1814. He performed this particular surgery at UK, at the York Hospital, Chelsea, on His Majesty's Army man who had a nose mutilated then. And of course the description goes, so it goes, it says that it took less than quarter of an hour, that is about 15 minutes. The person who underwent the operation had a lot of pain, obviously understandably so, that the cuts and all would be made. Probably the British were not aware of the painkiller, what we call as cannabis. Those of you in the audience who have consumed cannabis, like me, would know the properties of cannabis, and it's great. I'm sure many of you have done that in the audience, but it's great painkiller. And I'm going to come to cannabis a little later on why cannabis should be legalized, and why cannabis's illegalization has been irrational. I'm going to come to that a little later. All right. So this is one of the first examples I actually wanted to show you. When ancient practice meets modern science, how much benefit actually it can bring to humanity. So we don't have to be really dismissive of ancient practices, some of these, which we can actually find rational of that and do this. I'm going to give you some more examples, right? And we actually start now moving towards the modern era. And the second example also is from the example that I want to give you is how people from the West, when they actually started coming to the East, and how they started realizing the mix of the two, and how the cultural differences between them yet brought them together in addressing some of the problems of humanity, which we actually need to do even more today. So this example is about a Dutchman, the Governor General. The Dutch had a colony in what today is called Kerala, and the person is called Van Reed, Hendrik Van Reed. He was the Governor General of that particular era. And Van Reed actually became aware of the use of medicinal plants in India. And Van Reed thought that this knowledge must go to Europe along with him. And what he did extensively over a period of a few years, he went to Kerala, he took help of some of the Ayurvedic doctors, the principally person called Iti Achudan, and together they put together an atlas of all the medicinal plants of Kerala. Now remember, this is about 70 to 80 years before Linnaeus himself. You know? So the first atlas on the medicinal plants and their classification was made by Van Reed almost 80 years before Linnaeus. And the major motivation, of course, was to categorize the medicinal plants that have been in use in ancient practices. The ancient medical practices in India, what we call as, one of them is called Ayurveda, and others are of course Unani, Siddha, and so on and so forth. And of course the realization was that there is enough knowledge, or rather there is a rich knowledge in the ancient practices that if we exploit today can be extraordinarily useful, right? And this is one fact that many of the modern people like us, some of us in the audience, dismiss, saying that ancient practices were irrational. But there's a lot to learn in people like me. We believe that there is a lot to learn if you bring actually both these people together, and humanity only in the end actually benefit by this. I'm going to give you some more examples, right? So the first actually I give you about Renoplasty. It is used even today. Those who are surgeons in the audience here would know Renoplasty, the same procedure is used today, except the fact that the painkillers and all are actually different. But cutting the skin from the forehead or the cheek is used even today for the nose reconstruction. Okay. This is the second example. What I actually want to show you is another example which is described in the ancient texts in India. Is called Sarpaganda, right? I mean, it's a plant which is called as Rauwolfia serpentina, and has always been used in a sense that it was known to have medicinal properties, right? And the medicinal properties, of course, then was not known, but I mean, what people thought that when you are uncomfortable, this used to be actually given. And Sarpaganda, essentially, when modern way we started looking at it, turned out that it's a great hypotensive. So the people who have hypertension, this actually can be given. And the first person who did clinical trials in India was Colonel Ramnath Chopra. Is a great person. Is the person who was working in Calcutta then, but he is also the person who wrote India's Drug and Cosmetics Act in 1943, and also the person who established what is today called as the Indian Institute of Integrative Medicine in Jammu. He's the one who actually started this. And he recognized that there is plenty of knowledge, a rich knowledge that exists in the classical literature about the use of medicinal plants, and some of that can be exploited even today. So he actually did clinical trials on this, and this particular medicine is used even today, right? I mean, Riserpin is used as a hypotensive. The US FDA gave a clinical approval in 1955. Is not the frontline hypotensive today, is the second line drug that is given because the other hypotensive that has come in the market, they're actually more effective, but nonetheless, Riserpin is still in use. You know, I mean, that's the fact that we should actually recognize the fact. And Riserpin also has some other effects. It was turned out that it actually also has effect on serotonin and things like that. And the fact that fascinated none other than Arvid Carlson. And Arvid Carlson and Bernard Brody actually then studied extensively the mechanism of action of Riserpin. And those who are neuroscientists here would know that the rest is history. You know, so the discovery of many neurotransmitters and how they actually came about actually has the origin on the work of Arvid Carlson, what he undertook at the beginning of his career on Riserpin. But the origin of Riserpin, of course, is in the ancient texts, what we call as the Sarpaganda in our this thing, and that's acknowledged. I'm not talking of pseudoscience, I'm not anti-science, I'm not talking irrational. What I'm talking is that there has been a mention in the ancient texts that was proper clinical trial was done by Ramnath Chopra, has been in use in modern medicine, and the mechanism of action is fairly well established. Right? So these are the kind of things, what I say is that if we come together and try to find a middle path, probably will bring a lot of value even to modern medicines. People in China, of course, have recognized that fairly strongly. And what US FDA today calls is a category of drugs, something called botanicals, what Indian CDSCO or DCGI calls as phytopharmaceuticals, is a completely different class of drugs. Botanicals are a mixture of compounds, not necessarily one single purified compound. It can be a mixture derived from a natural source, has to have a characteristic signature of that particular one, and if it's made under proper GM facilities and has been shown to be of clinical use, can actually be used. And number of botanicals have now received FDA approval, and number of botanicals are actually under active development even today. But most of them are from the Chinese ancient knowledge. Some of them are also from South American ancient knowledge. But what we believe is that if we were to able to exploit Indian traditional knowledge on this, even Indian people would have a good wealth of knowledge that is available in our literature on the medicinal properties of these plant extracts and so on and so forth. I just want to digress a little bit here before we go over to the modern drug discovery. What I want to say is that the modern drug discovery, the way it stands today, is about only 125-year-old phenomena in which we tend to say that a disease is because of a single cause. It could be a bacteria or a virus or whatever. It could be a mutation in a gene. It could be a number of mutations in genes, but it is a single cause for a disease. And to suppress that cause, you need a single organic molecule which will suppress that cause. Now this is a modern paradigm. However, in all the cultural practices around the world, it was recognized that disease probably is not a single cause, is a combination of multiple factors, including environment, including our eating habits, and so on and so forth. And therefore, to get over the disease condition, we must actually have a holistic approach, whether to improve your health, let us say by nutrition, or by changing certain kind of environments, or things like that. And because of that, most of the ancient medicines that what we see is probably more holistic, which considers the environment of a person and also places a lot of emphasis on what kind of diet and all that person should have to overcome the disease, right? And there is a more holistic approach. Now, once again, we have to learn to have a middle path of this. And when we actually try to understand mechanism of diseases, and when we want to try to overcome those mechanisms, we should actually consider this middle path once again to see whether we can do better in this. Let me come to even closer in time today. And I want to take the next example. And this is one of the finest examples of how drug discovery actually began in India. This is one of the first examples in the modern sense, in the modern drug discovery, in the paradigm that I mentioned, that one disease, one cause, one compound. And the person who actually was working was somebody called Upendranath Brahmachari. He was working in Calcutta, and he was working on leishmaniasis, and he wanted to find cure for leishmania then. And what he did, in 1922, he synthesized a compound called Urea Stibbean, and then what he showed initially through animal experiments and later on with human trials and so on and so forth, that it brings down mortality in leishmania dramatically. And these are his notes taken from his book, that sometimes in that particular period, in a period of about 10 years, between 1925 and 1935, how many people actually were cured of leishmania because of Urea Stibbean. Now, it was recognized the fact that in 1925, about 90% of the people who were bit by sandfly would essentially perish. Right? The mortality rate was very high in leishmaniasis. By 1935, in a period of 10 years, 90% people who had been bit by a sandfly and had leishmaniasis and had started taking Urea Stibbean, 90% people had survived the disease. So from the fact that 90% mortality rate to 90% survival rate is absolutely phenomenal, right? And this was one of the first drugs from the modern drug discovery perspective that was actually done in Calcutta by Upendranath Brahmachari. So what I've said here is 90% survival rate against 90% mortality rate is absolutely phenomenal. right? And Urea Stibbean is even used now, is now a second line, once again, anti-infective. It was only the second compound, anti-infective, which was discovered at the Sarpaganda, much before penicillin and sulfur drugs were actually made. And very few people are actually aware of this part of history, that what he had was great opposition in making this particular drug and marketing, until he really demonstrated that people can get cured of leishmaniasis in that particular period. So it's 1920s, 1930s is what we are talking about. Now, because Debashish asked me to talk of biomedical sciences in India, I'm coming closer to time. I want to come to post-independent time, and I'll come back to this theme once again, right? So this particular theme will come back at how biomedical sciences, and especially pharmaceutical sciences, have been developed in India. I'm going to digress now from this particular topic, because I wanted to talk about some of the developments of science in India, biomedical science in India post-independent. I could have picked up many different examples. I could have picked up examples how Obed Siddiqui brought to India the concept of model systems, initially working on E. coli, and then later on moving on to Drosophila. There's a fantastic example. How the molecular biophysics unit in Indian Institute of Science was developed, and did some phenomenal work from 1970s till recently. So there's another part of history I could have talked about. I could have talked about Shambhunath Dey, who discovered exotoxins, and none other than Joshua Lederberg became a fan of Shambhunath Dey. The entire area of exotoxins begins with the discovery of chlorotoxin in Shambhunath Dey's laboratory. All the exotoxins or toxins that bacteria make were discovered beyond chlorotoxin that were discovered by SND. I could have talked of Subhash Mukherjee for the IVF procedure, but I'm going to talk of more better known example, but lesser known facts about a person who actually contributed enormously to how we actually understand protein structures. And this example is a very popular example, but what he actually did beyond certain facts that most people wouldn't know. So the person is Jain Ramchandran. Many of you know that Linus Pauling, on his 50th birthday, has communicated 7 papers to Proceedings of National Academy of Sciences, and the 7 papers were published on his 50th birthday, and they changed the face how protein structures are understood today. The concept of alpha helix, beta sheet and all was one of those 7 papers, or rather 2 of those 7 papers. Very closely after Pauling proposed that, in 1953 came the model of the double helix, DNA double helix. 1954, the third major biopolymer structure was solved, and that was of collagen. The structure of collagen was solved in 1954 by Kartha and Jain Ramchandran, and the structure was very heavily criticized by Crick and Rich, the Francis Crick and Alexander Rich. They criticized the structure because they felt that there were short contacts in the collagen structure. Irrespective of the fact that Rich and Crick were working on the double helical structure of collagen, what Ramchandran showed is actually triple helical. It's not a double helix, but then Crick and Rich, of course, modified their model, and within a few months of Ramchandran and Kartha paper, they also published their triple helical model, showing, or rather suggesting, that Ramchandran's work actually was wrong and the Crick and Rich model is more right. And of course, the history is testimony to the fact that Ramchandran model still stands tall today among the collagen structures. But nonetheless, the criticism stung Ramchandran so much that in late 1950s, he undertook something phenomenal analysis and asked a question, a very basic fundamental question in chemistry. And the question is, how close can 2 non-bonded atoms approach each other? If atoms are not covalently bonded, how close then they come? The answer was very obvious to the chemists of the day. And the answer was very simple. If atom has a van der Waals radius, right, the 2 atoms have their van der Waals radii, the closest they can come is the sum of their van der Waals radii. It's an obvious answer to all the chemists. Ramchandran undertook an analysis of all the organic structures that were available then in 1950s and showed that this is not true. Atoms can also approach closer than that. It's not only the sum of van der Waals radii of atoms, but they can come closer than that. And that's phenomenal. People like Pauling and all were astonished that how does this happen? In fact, Pauling made a personal visit to Madras soon after Ramchandran published his paper in late 1950s. Both Linus Pauling and Dorothy Hodgkin made personal visits to Madras to understand how Ramchandran was actually doing all these calculations. And armed with the fact that atoms can come closer than sums of their van der Waals radii. For example, I've shown you here the potential energy. This is the sum of van der Waals radii of atom, where atoms can come even closer than that. Of course, this becomes very repulsive, so they won't actually come that close, but they can come up to this particular distance. And based on this, he defined what are called as hard limits and soft limits, and he made a Ramchandran plot, which actually in today every biology textbook shows a Ramchandran plot. Right? And that's a phenomenal work of what he did. And in fact, when he wrote this particular paper on collagen, structure of collagen, he reads here, probably you will not be able to read there, but I can read it from the screen here. He says, in fact, if Rich and Crick's criteria were adopted, some of the accepted structures, like the alpha helix, will become unacceptable. Secondly, the study of relation between NH and OH hydrogen bond and other things also shows that atoms can approach closer. So if Rich and Crick, Alexander Rich and Francis Crick were true, even alpha helix would become unacceptable, right? So the fact that in the triple helical structure there are 2 hydrogen bonds and not one as proposed by Crick and Rich actually stands even today, what Ramchandran proposed in the collagen structure then. But of course, because of the criticism, he did some phenomenal work later on this. Many of us consider Ramchandran's contributions far bigger than some of the even earlier Indian icons in physics and so on and so forth, because Ramchandran actually went on to show many, many fundamental things that are used even today by structural biologists around the world. For example, Bijvoet had shown in Netherlands that when you are analyzing crystallographic data, there are 2 kinds of diffraction maxima that you see in the crystal diffraction and have different intensities. And because of that, you can what we call is a phenomenon called anomalous dispersion, because they are expected to have the same intensity, but they end up in having different density if there is a metal or something absorbing X-rays. Ramchandran showed that this particular method can be very powerful method for crystallizing, analysis of the structures and for solving the structures. And today, in fact, one of the most dominant methods of solving crystal structures is what is called either SAD or MAD, that is single wavelength anomalous dispersion, or multi-wavelength anomalous dispersion has its origins in the Ramchandran's early analysis of how it can be used in solving crystal structures. So the most dominant way of solving crystal structures today is the SAD or MAD, that has its origins here. But even more important, he published a paper called an apparent paradox in crystal structure analysis. And this method had its origin in crystallography, whether the diffraction maxima or the intensities of the arise of the diffraction, they are more dominant in a Fourier analysis or the phases that are used in the Fourier analysis. And what Ramchandran was able to show is that phases play so much more important that if you use wrong phases in your structural analysis, that will lead to some sort of bias in your structure. And that once again is used even today by crystallographers all around the world, how these phases actually play such a dominant role and how you should not make a mistake in wrongly building your structures in electron densities and so on and so forth. This method is used even today and absolutely phenomenal, whether it be the structure of collagen or his proposal of anomalous dispersion and how actually phases play such important role in this. The fact that Ramchandran was not recognized what he was due international is a different matter, but nonetheless, he's done absolutely phenomenal work which is relevant even today. Okay, I have digressed enough going to the fact. Let me come back to pharmaceutical discoveries made in India, and I want to give you an example of one of the drugs that has been approved for TB very recently, about 4 or 5 years ago, is something called Protaminate. It's a class of nitroimedazoles. David, you're aware of that. Nitroimedazoles were first synthesized in Ciba Geikie in Mumbai. Right? A class of drugs, nitroimedazoles, were discovered by a person called Nagarajan, one of the finest medical chemists that India has produced in the last 50 years. Absolutely finest, one of the finest chemists. And he was working on a class of drugs called nitroimedazoles, actually starting from here. And he made a series of compounds. And then he tested this on animals. And he was actually working on multiple different diseases, and then he showed that in TB model of animals then in 1980s, late 1980s or early 90s, that this compound actually is extremely effective, what today we call as Protaminate. So he wrote in his review some years later that if any one of these compounds is useful in the clinic for treating TB eventually, the scientists of the Goregaon Research Center, they will feel very fulfilled. And indeed, Nagarajan unfortunately passed away about 6 months ago. And he was a very happy man, I'm told, that eventually when the clinical trials of this were finished and the drug received approval around the world, what we call today as Protaminate. So it was synthesized in Nagarajan's lab in Ciba Geikie in the late 1980s, and the initial work was actually done in his lab. So they're the kind of actually thing that actually happened over a period of time. What I've actually traced till now is some part of history from our cultural practices and shown that if these cultural practices, some of them are analyzed from the modern perspective, how much benefit actually can bring to humanity. And actually we have to recognize this particular fact even today. I think this is some of the things that because of the debate that we get embroiled in on both sides, unfortunately we are not able to realize the middle path which can be very useful. I want to give one example of cannabis, and then I will come to some of the traditional knowledge, one example of traditional knowledge from the UK. You know, not from India alone, because I have actually till now focused on Indian traditional knowledge, but also one extremely important molecule that exists today, and that came from the traditional knowledge in the UK, right? But before that, I just want to make a very brief comment on cannabis. I think it's somewhat nonsensical that cannabis has been banned over the world, its cultivation has been banned. Cannabis, we have to legalize cultivation of cannabis. And we have to legalize, if we want, we can do something called low THC cannabis, the one which probably does not make you addicted, low THC and high CBD. If you are able to do that, I think it can bring huge amount of benefit to this. Now, cannabis is described in ancient literature, Indian literature, as one of the 5 major plants that actually be used for medicinal properties, right? So the 5 plants that have been described, one plant is that of cannabis. It has great properties in terms of anti-pain relief and so on and so forth. And I'm very pleased that during my tenure in Delhi, we were able to actually get at least one cannabinoid in a clinical trial. The clinical trial as we speak today is going on in the Tata Memorial Hospital in Mumbai. It's a collaboration between ICMR, the Department of Biotechnology, and CSIR. And we're actually able to push our will through the drug controller and all, and saying that the cannabinoids must actually get into clinical trials. And in fact, I'm also happy that the kind of lobbying that we were able to do when I was in Delhi, and principally I had to talk to many people who are politicians and chief ministers and health ministers of different states and all, that a few states have actually now legalized cultivation of cannabis. Uttarakhand has legalized, I believe Manipur has legalized, and so on and so forth. But we have to be aware that cannabis, of course, can be addictive, and therefore when we legalize the cultivation, we should probably try to see whether we can get low THC variety, the one which is less addictive, and do that. And many of us in the audience have consumed cannabis, so we know how nice it is actually to consume cannabis once in a while, not every day. And especially in March, there is a festival here that I would urge Deputy Welcome Trust Alliance to have this fellows meeting at that particular day. All of us can actually enjoy cannabis at that time. And you get plenty of cannabis in terms of what is called bhang at Charminar area, and it's really nice. So anyway, but has good medicinal properties, and I think there is a chance to exploit these medicinal properties of cannabis. It's an extremely effective painkiller. In fact, there are many stories about people who had consumed cannabis and then had injuries later and did not realize that they had injuries. It's an extraordinary painkiller. So, and especially in terminal cancer patients, I think it has a great use for future, and we must try that out as we speak today. Okay, to the last part of my talk, I want to talk about international cooperation, so that we can bring some benefits to humanity. The kind of international cooperation that we see today with between the Department of Biotechnology and the Wellcome Trust is actually phenomenal. it has brought so much benefit, not only to Indian science, but the kind of discoveries that have happened actually is taking science, the world of science forward. And these kind of cooperations must continue. If there was ever a doubt in anybody's mind that this kind of collaboration should not continue, please call me again to convince you why these kind of collaborations are must for furthering our knowledge. So example that I want to take you now is the last example that I would like to take, and it is actually taken from British history, not Indian history now, the traditional British this thing, and how actually Henry Wellcome used this particular part of history so that Henry Wellcome was when he was developing his career. Now, Henry Wellcome himself was a great proponent of innovation and how actually modern medicine can benefit from traditional knowledge. Wellcome had recognized this particular fact. Two examples of that particular one. One is, of course, this happened after he had passed away, unfortunately. Henry Wellcome passed away in 1936. And digoxin, what Burroughs Wellcome had undertaken the trial, received approval just before the Second World War. It was the last major drug that was discovered just before the war, digoxin. And Burroughs Wellcome had undertaken the synthesis of digoxin, and Sidney Smith at Burroughs Wellcome had isolated digoxin from this plant called digitalis, and the Burroughs Wellcome actually started manufacturing that. And Burroughs Wellcome, when they started manufacturing this drug in India, they had two major products when they started manufacturing from Bombay. One was Hazelin Snow, and other was, of course, digoxin. And the Burroughs Wellcome actually made a lot of wealth out of compounds like this. Now, the point I'm showing this is because although this happened after Sir Henry Wellcome's passing away, Sir Henry Wellcome was aware of traditional practices in other parts of the world, in China, in South America, in India particularly, and he actually wanted to exploit this traditional knowledge so that we can actually use this for modern pharmaceuticals. And with that particular purpose, Sir Wellcome sent one doctor of Indian descent to India in the 1920s. The doctor's name was Pyramol. Pyramol was of Indian descent. He was sent to India so that Indian traditional medicine actually could be catalogued, could be brought back to Burroughs Wellcome, and Burroughs Wellcome can actually use that particular one. Pyramol was sent for 1 year to go travel across India and catalogue and write about Indian traditional practices and what kind of compounds were being used for what kind of disease conditions. Pyramol ended up in spending 11 years because 1 year he'd found that was not enough to cover the entire length and breadth of the country, and did some phenomenal job and took it back to the UK and did that. Both these examples actually show very close to the Wellcome Trust's heart that even Sir Henry Wellcome was aware of the fact that traditional knowledge can be used for modern medicines. And this one aspect that actually I have seen among the fellows is actually had not been presented. Maybe there are fellows who have posters, but how phytopharmaceuticals actually can bring value to modern medicines, or what US FDA calls as botanicals, is I think something we are missing out. And we must once again find people, or we must support people who would work on areas such as this, learn from traditional knowledge, and try to see some of the traditional knowledge can be used in modern practices. Maybe we can actually set up experiments the way we do for that. If you do that, I think I have no doubt in my mind that it will be good for the mankind in the long term. And when we talk of the mankind for the long term, my final passing comments is let us review how we are actually doing on the Sustainable Development Goals. The 17 Sustainable Development Goals were defined about 7 years ago, about 8 years ago, in the Paris meeting by UN, and is exactly halfway through. The Sustainable Development Goals we are supposed to meet by 2030, and the 17 goals, how actually we are doing exactly halfway through, is a report that was presented about a month ago by the Secretary General United Nations. And these are the 17 SDGs, and the ones which are immediately relevant to this particular audience are things like end poverty. How are we doing ending poverty in this particular one? And what we see here is a fair progress is yellow, on track is green, we are not on track in ending poverty. There is stagnation. What we'll see is some amount of stagnation in ending poverty and so on and so forth. Sustainable Development Goal 3 is healthy lives and well-being. There is some progress, but huge stagnation. Yeah, the red thing is stagnation. Sustainable Development Goal 5, gender equality. How are we doing on that? Right? And we see here on gender equality, there is some progress, there's fair progress, but there's still long way to go. And to reduce inequality within and among countries, and that's where actually we are not doing well. When they reduce equality among countries, we actually need to do much, much more doing that. So when we are talking of inequalities, what we are finding in the last about 30, 35, 40 years is the inequality within countries are actually growing quite rapidly. In all the major advanced economies, the number of people who hold most of the wealth is a very small amount of people. And number of people who live in poverty is a large number of people. So there is great amount of inequality that exists in even the advanced economies. But what we see is that the inequality among the nations also is growing. And we must address this particular problem. And this problem became so prominent during COVID period that it was committed by everyone that vaccines would be made available globally. Did we see that? Did we see any of the vaccines reaching the countries where they were most needed? I think our community as a whole, we failed to address this particular problem. And I think we all must be shameful of ourselves that why we did not actually make an attempt to convince countries that vaccines and global health access must reach areas which are inaccessible or less endowed. We completely failed, our community completely failed in this particular aspect, right? Our community does a lot of talking when it comes to other issues, but when it comes to inequality, we are actually nowhere in talking of inequalities. The science, as we practice today, sees great amount of inequality, right? You look at the number of papers that are published from countries which are not as endowed as countries which are more endowed. You look at the number of memberships of editorial boards from countries which are very endowed and countries which are not very well endowed. How many people you see in the editorial boards of those things? You see people talking in conferences about how many people are talking from essentially countries which are extremely well economically and countries which are not. Is it true that no science happens in those countries? Is it true that there are no brilliant people in those countries? Is it true that they actually can't do the science the way it should be done? Can we not take them along with all of us? I think this is the point that we must ponder and we must try as a collective thing to address some of these questions. I just want to show one example, my last slide, that how India actually was working towards ending poverty. Of course, this before the Sustainable Development Goals were defined, and how we have actually done in last about 15 years. And the numbers are staggering. So when we are actually taking the review, the halfway estimate of meeting the Sustainable Development Goals, this particular statistics came from UNDP that 415 million people, Indians, have been lifted out of multidimensional poverty in last 15 years. And if our targets are focused in that particular sense, irrespective of which political power is in power, which political party is in power, if the society resolves that we have to address a particular issue, I think problems are not insurmountable. We heard about TB today, the TB talk, how prevalent is TB. We also heard about other diseases, mental disorders and all. They're all very prevalent in countries like ours. But if we resolve how to solve them, if we get policymakers, if we get scientists, if we get politicians and all together, I'm pretty sure we'll be able to solve this thing. And the COVID period was a great learning experience. I cannot thank but my stars that happened to be in Delhi as a bureaucrat then, and we were able to actually collectively raise this awareness amongst everyone together. And together with politicians, together with industrialists, together with some of the policymakers, and together with scientists, we were actually able to come on the board and we actually were able to address the COVID issue at that particular point of time. and reasonably well is what I would say. I just want to make a point that when we take, coming back to my first point of where I started, that when we take positions, very hard positions on culture versus modern science, on colonial powers versus their colonial occupation, very often we don't realize is that the system itself is fairly neutral. As long as we have democratic voice, the system is fairly neutral. I just want to show you that irrespective of whichever political party is in power, at least in India, the support to science has always continued. And the support to science is actually very core to India's tradition post-independence. This is a statement that most of you will not be able to read from far off. This is a statement from Pandit Jawaharlal Nehru. He said that science and science alone would be able to address the problems of society. And here is a statement from another prime minister from a different political party about help the soldiers, help the farmers, and help the scientists. You know, Jai Vigyan, Jai Kisan, Jai Jawan, Jai Kisan, Jai Vigyan. So irrespective of whichever political party is in power, trust me, having worked in Delhi, that supporting science is everybody's agenda. Do not be under false impression that different political parties have different agenda on science. So let us agree to that particular fact. Let us agree to the fact that we have to take a central view on all the issues and not take very extreme positions in whatever actually that we debate. And trust me, the press always will present only the extreme views. The press will never present a centrist view as what we want to take, because otherwise the newspapers and the magazines will not sell. Whichever newspaper and magazine that you talk of will not sell if they present views like ours in that time. So thank you all very much for your attention. I hope that I have not talked complete nonsense. I hope I have made some sense in the thing. And I would be very happy to take questions. Thank you very much.
Thank you, Professor Mande, for your enchanting, captivating talk. We have a lot of questions.
Sir, I'm very, very grateful for giving this talk and for propagating what you call a middle path. For me, your talk highlighted issues of political economy of knowledge and about science leadership as opposed to just doing good science. And here I had a short comment. I'll be very brief, please bear with me. I would like to highlight what I believe is the very unique aspect and strength of India Alliance, but also would like to provoke India Alliance to do more on this. I'm a dentist who moved to public health and who now studies history. And when I applied for my intermediate fellowship in 2018 under the clinical and public health track, I was not very hopeful because all the prior awards that I saw were all about clinical sciences. And I was talking about doing political economy of tobacco in India using historical methods. And I'm so grateful, where I was very pleasantly surprised when I got the award of my intermediate fellowship. And now, in fact, I got a senior award for very similar work to track, public policy since colonial India. And one of my reviewer mentioned a term which will stay with me. He says that this is more about public health humanities, and that's exactly what we want. And so I think I would say that India Alliance, I really appreciate that the India Alliance takes that kind of a broader view of science. But I think still, when we talk about interdisciplinarity, I think we are still talking very, very limited way of very sub-disciplines or fields within what we may call biomedical science. But I think if we are really talking about biomedical, clinical, and public health, I really believe public health is much about social sciences. I don't know why we don't call public health a social science, but even within basic and biomedical science and clinical science, when we are talking about how our findings impact society through policy or practice, that kind of knowledge essentially comes and informed by social sciences. So I'm so grateful that you made this talk, and I really hope that I see more of people from social sciences in such gathering. Thank you so much, sir, for this talk. Thank you.
Can we just skip this question for that?
You said that you highlighted how the distribution of vaccines during the pandemic was so unequal. And it's a really important point. And just earlier this week, together with one of my colleagues here, we were at the International Pandemic Sciences Conference in Oxford. And about a third of the speakers spoke, let's say, eloquently about how much work and goodwill is going on towards more equitable distribution of vaccines, CEPI, different organizations and so on. But I asked a question that wasn't answered, and that was, what has actually changed on the ground? If we had another pandemic 3 years from now, would it be any different? And the answer is no, because again, the rich countries will protect themselves first. And actually, what made the difference was India and China's indigenous manufacturing capabilities of vaccines, which supplied not only themselves, but other countries, other developing and low and middle income countries. The West did a tiny fraction by comparison. And so, just as the last speaker pointed out the value of the interdisciplinarity of the India Alliance, I would like to point out its value in building indigenous scientific infrastructure here. Because when push comes to shove, you cannot rely on the West to help you, no matter how much volume of hot air and acres of reports and documents are written. In the end, when the pandemic hits, the drawbridges get pulled up, every country protects only itself. So having our own scientific infrastructure here and the sort of scientists that India Alliance supports and develops will be the ones that in the future will be creating, producing and disseminating new vaccines and other new tools to protect against future emerging public health threats. Thank you.
Thank you. I think completely agree with you. I think we need to do doing enough. Our community is not doing enough in building scientific capabilities in those countries at this moment. Trust me, I was in Government of India and I was engaged with discussions at the highest level, even with companies like Pfizer and Moderna and so on and so forth. And these companies had committed that mRNA technology would be made available to other countries. Ask a question, has that happened? We were trying to bring these companies to India, and I was personally engaged with discussions with them. When Gilead made Remdesivir available, I was one of the persons who negotiated with Gilead to bring that to India. And we had to actually literally threaten Gilead that we are going to break the patent. Because at that moment that Gilead actually said that let us not break the patent, we will give what is called as a voluntary assignment to Indian companies. But despite the promise made to WHO and to other countries that mRNA technology would be made available to others, it has not happened. And even if that were to happen, I don't think there is capability in Southeast Asia or in Africa for manufacturing those on today's day. I think as a community, all of us have not paid enough attention in building up capability there. I completely agree with you on this particular aspect. And therefore, one of our agendas has to be in building capabilities in countries which are less endowed, the scientific capability and their manufacturing capabilities, so that they also become self-independent for the preparedness of future pandemics. Thank you very much.
I wanted to go back to the first part of your talk about the need to avoid extremes and the need to incorporate traditional knowledge, both of which I agree with. And I guess artemisinin is a nice example of something that came from a traditional route and then its drug action was identified. I guess the point I wanted to make is that understanding the role of evidence is something that both extremes, strangely, ought to do better on. I mean, even in the extreme traditionalist view, understanding of what constitutes evidence in favor of a particular action, even if you may not understand it at a microscopic level, that is important to know, that to be able to change your mind depending upon the evidence that exists for a particular mode of action. But it's also true that on the extreme science side, it is very hard to change the scientific literature. There's lots of levels of gatekeeping, and often there are ideas that survive simply because they're historically there, even in the face of evidence that scientifically some ideas may not be true at all. So I like the idea that we should function in some middle space where we're conscious of both ends, but importantly understand the role of evidence, which I think is really crucial, whichever side you happen to belong to.
Yeah, thank you. I strongly believe in middle path in all aspects, not only evidence and scientific evidence or even other aspects of social science. The middle path always actually helps in taking very extreme positions. So, thank you.
Thank you, Dr. Mande, for the wonderful presentation. I have a question with respect to your second last slide. Although our country has seen a lot of progress in the biomedical sciences, more so in the recent years, however, the concern for women in science, especially with respect to promotion of women's science and gender balance, still remains a concern in our country. So what is your take on that, and any experiences that you would like to share, and what more could be done?
I agree with you on this. I had my own fair share in science administration, and while I was there, I personally did try to see whether the participation of women can go up in science. I will give you my own example. I mean, because I was involved with the CSI. So when I took over CSI Director Generalship, out of 37 labs, there was not a single woman director, right? By the time I left, there were 7 women directors. Many of the labs, their research councils, did not have women representative, especially the engineering labs, civil engineering and electrical engineering, did not have a single woman person on the advisory council of those. I made sure that there was proper gender balance in all the research councils. So much so that the Research Council of Institute of Genomics and Integrative Biology, when they came back to me and they said that we have 80% women on our research council. I said, that's okay, that's not a problem. So we should actually try to involve them. So the only way it can be done to address your question is by resolving that we are going to do it. You know, I mean, today what we see, for example, not a single IIT has a woman director. I mean, you have seen Preeti is going to now become the first director, but she's going in Zanzibar as an IIT director. But in India, out of 23 IITs, there is not a single director. IISc never has had a female director. And unless we talk about it, and unless we actually increase the awareness amongst people and put pressure on the administrators, this is not going to happen. I'm very sad to say, I was member of IISc's council, Indians of Science Bangalore Council, and my own department where I came from, the Molecular Biophysics unit of IISc, did not have a single female faculty member, right? All male faculties. And I made sure to minute in the council meeting that MBU or the Molecular Biophysics unit should stop all the recruitments unless they have hired a few female faculty members. This minuted. So in the official record of IISc council, you will see that I have said that unless they hire a few female faculties, they should not be allowed to hire the next faculty member. You know? And unless we actually raise these issues at a very high level and keep talking about them, I don't think we'll be able to solve this, right? It's not only talking about in this room, but also talk to all the policymakers at the highest level that these issues have to be addressed. They are hard issues, and unless we actually start addressing them and taking some corrective action, we'll not be able to do that.
We can have one last question.
The point that you raised about striving for equality, you know, the people who are sitting here, they do not always have the sort of power or ability to change things countrywide, worldwide, whatever it is. I think at least as far as the selection of fellows in this program goes, there is a great deal of deliberate policy that will bring up the number of female scientists, and this is something that is maintained as a policy without any reason have to be attached to it. And I think you will see, I don't know what the past may have been, but you see that the number is going to go up because our number of PhDs who are female are much higher than the number of men. And so now the question is whether they get into the pipeline of, professoriate. And that is the aim of the Wellcome Trust here. And at least as far as we are concerned, that will happen. That has to happen, and that will happen, and it's happening. So in this small community, we will do what we can. And then we have, people who have power, and they can try to talk to the...
I don't have power anymore, huh?
We have one last question.
Yeah. Thank you, sir. Thank you for medicine. And I'm a doctor in I also have been a doctor in a remote Adivasi area where we have a public health research field station. I wanted to invite reflections on two aspects, and again a little bit of two extremes. You spoke about Ayurveda and traditional medicine. It was very wonderful insights on how there has been so much extraction from Ayurveda and traditional medicine on one hand, with limited acknowledgement, and now in fact a kind of saying, oh, some of these might be superstitious, etc. But there are two aspects to it, sir. One is in southern Karnataka, remote rural areas where I work, a lot of traditional practices are actually not formal Ayurveda. So there has been, I think for a long time, this divergence between folk medicine and traditional medicine, like many of our Adivasi communities use, and formal Ayurveda, institutional Ayurveda, which has taken a more modern medicine-ish institutionalized way. And the other extreme is Ayurveda pharmacy, which also behaves in as predatory ways as modern medicine pharmacies with respect to regulation and various aspects. So I just wanted to hear your reflections on this, because sometimes when I engage with discussions on Ayurveda and traditional medicine, there is complete homogenization and lack of looking at these differences that exist in society, and also linking then to the part about the role of how we look at evidence, the politics of evidence also, and the role of medical humanities in resolving some of these dilemmas. Thank you.
Yeah, thank you. Just to comment upon that, speak much more about Ayurveda or Unani or Siddha, and not much about the practices followed by the tribals. And there are many parts of the world where these practices have evolved over centuries, right? And we must actually go back to some of the scientific rationale of those. My example of digoxin was specifically targeted that we are not the only ancient culture. Humanity has existed all over. Digoxin was discovered through a gypsy who used to live in UK, and the doctor at the time approached her to get the knowledge out of her before digoxin was eventually synthesized in Boroswilka. CSIR on its own part, CSIR where I was the last 4 years, has actually started an initiative of documenting all the traditional knowledge in the country, not Ayurveda alone. And there's something called a traditional knowledge digital library that has been created, about 400,000 entries in that on today's date in digital format. And most of the patent offices around the world actually access this particular library before any new patent is granted. And we are actually trying to lobby at this stage to say that patent offices mandatorily must look at the traditional knowledge digital library before the grant of intellectual property is given to an inventor. If the knowledge has already existed in traditions, let us say in Africa, then obviously it doesn't make sense that some inventor actually tries to exploit that knowledge and make wealth out of that without the traditional practitioners of that getting any benefit out of it. And the whole purpose of creating this traditional knowledge data library was that one. So I completely agree with you. Traditional knowledge is not only with Ayurveda. We also speak about Ayurveda much more than what we should speak about tribal practices. And there's plenty of wealth of knowledge that exists among different parts of the country, among different parts of the world.